Namaskaram to all of you. I'm glad that I'm back in SN College, Shivagiri, Varkala with the mathematics department. That too in the honor of late R. Shankar with a webinar series which is called Trends. And the topic which was suggested during the communication by Dr. Sanma was calculus and its real life applications. Thank you Dr. Neelima, the HOD, and thank you Dr. Preeta for this connection and connecting me to the bunch of students probably who are aspirants of learning mathematics. Last week I had a session, so I found that there was only one student from history department who contacted after that. That was only one communication. I also posted the video and glad that some of the faculty members are following not only that, other videos on YouTube also, and I am getting the comments there, so I am very happy that Dr. Simi is with me. Calculus is a beautiful subject. In mathematics generally we say a circle. Yeah, now if students or anybody who wanted to follow the talk, they should have a pen and paper. Not only mathematics, any lectures. I believe in two aspects, note taking and note making. And the best student is one, probably they will write down these are all the points which I loved and then send a message. Or maybe the best student could be one who makes a real note and then posts something. I remember long back when I gave a talk in St. Teresa's College, the topic given was to be the best. But then after some time I wanted to check whether such a topic is given by somebody else, or maybe how many such topics similar to that is given by me myself. I was searching the topic, then I found there is a beautiful blog written by one of the student on what she learned from my class. I am 100% sure that will happen only when you have the habit of writing notes. When I am talking also, what I am doing is I am writing so that I remember what main points which I spoke. Sometimes some new thoughts will come, so unless you write it down, you may not remember after some time. Assume you want to ask questions, you should have the habit of writing notes. When you can hear and write, you become very good. I teach mathematics without a PowerPoint because I can visualize and I can speak seeing mathematics in front of me. So I believe that a good student is one who can visualize it and write it. Just now the Anaka gave the prayer and I was hearing the word Chil Surupam. I did not understand the meaning of the word. If Anaka knows, she could explain, I'll be very happy. Chil Surupam. What is Chil Surupam? I don't know. So what I do is I carefully look at word by word. I have written down Chil Surupam so that I can refer it later and then look at the meaning later. Chil Surupam, I have written down. This is what I do. If you don't understand, write it down so that you can learn it later, understand later. Right? Anaka has a meaning to explain, or somebody can explain a meaning. The word Chil Surupam, I don't know what is the meaning of chill. Okay, could communicate to me later if interaction is impossible. So I understand writing down, visualizing is possible only when you have a relation to that subject by yourself. In a theoretical education system, like today most of the education system, including the so-called BTech, engineering subject has become a theoretical education system, except for medical, because medical people have to attend patients and then treat them, so that's practical. A teacher would is successful only when the student can associate things around their life, at least visualize it. That has to be the mode of learning. If the student cannot recognize something as they have learned in the real life, whatever you teach will not be visibly staying in their mind also. So the class will become only a normal class, and after that they will forget this man or forget the subject which they learn. So let me take, how do you visualize? Maybe we can consider a circle, and that circle, while talking, Dr. Preeta was telling, the principal, algebra, trigonometry, geometry, all these are what we have. All that is developed through circle only. If the circle, if you cut it and take this half and then put it reverse, then you get a curve. That curve is sine curve or cos curve. I don't know how many trigonometry teachers explain like this. You take a circle, cut this into half on the x-axis, reverse it and put it, what you get is a sine curve. Now cut this half circle again and then put it reverse, and then what you get is a beautiful sine curve and cos curve mixed together. And the dimension, the arc, you add all the arc together, it will become 2 pi r, and the length will become shorter than 2 pi r multiplied by probably r or 2r if you put it down and up. If you continuously do it infinite number of times, very small pieces, that means these are like finite number, once, twice, and then 4 times, 8 times, 16 times, 32 times, 64, 128, 256. It's all power of 2, 2 power n. That many number of times, then what you get is a beautiful rectangle. Instead of circle, you can convert them into a slight polygon, or maybe infinite number of times when you do it, it becomes a rectangle. That rectangle will have r as a one side and pi r as the other side. Therefore area becomes pi r squared. That's how the circle has an area pi r squared. So you can visualize the area of a circle by cutting them into infinite number of times. So any finite into infinite is what we do for proving some of the items. You want to visualize it, probably you must look at the beauty of calculus. Calculus is the language which God speaks. That's what it says. Why calculus is important, I did not even ask. Why did you give calculus to me? Or I was not even given an option. I was asked to speak on calculus. I am so glad that Department of Mathematics in Varkala has got so much confidence in me that I can speak on calculus. The great mathematician Richard Feynman gave a beautiful talk in LA University a few years back, and that was called Calculus is the language of God. God speaks in calculus because we believe God understands infinity. The beauty of calculus is that, because God gives all beautiful things to us. I'm sure if you don't write down, you forget Richard's name, you forget Yale's name. So the lecture will become a useless lecture. Nothing was told. If you at least draw one circle and you wanted to know how that becomes 2 pi r into pi, you can communicate to me later only when you write it down, so that you remember that, yeah, there is something which has happened in the class. I want a clarification. Therefore, I reiterate the importance of note taking and note making. NOT, not note, NOTE, note. Note taking and note making. Okay, you want application of calculus. I can go abstract mathematics to mathematics like this and then say calculus is important. This is what is calculus. It is beautiful. It is God's given. But I am sure nobody will appreciate because you are not relating to your life. Okay, wait a minute. Let me ask you one question. Somebody is driving a vehicle too fast. I hope all of you are writing. This is a mathematics class, right? So you must write. Too fast. And the last 1 minute, the vehicle drove 1.2 kilometers. 1.2 kilometers. The last minute coverage was 1.2 kilometers. What is the speed of the vehicle? Let me see who is going to answer. If last minute speed was 1.2 kilometers, what is the speed of the vehicle?
Sir, please tell again question, sir.
This is the problem. No chance. Keep quiet, Harsha.
Okay, sir.
See, in any competitive exam, the time what you get to answer such questions are only 30 seconds. 1.2 kilometer is covered in 1 minute. Generally, speed we talk in terms of kilometer per hour. So what is the speed of the bike? Everybody is writing 1.2 kilometer. The speed is never kilometer. Speed has got a unit. In the chat box I am seeing answers, but I am asking speed. Speed doesn't have kilometer. It has got a unit. What is that unit?
Kilometer per hour.
Yeah, kilometers per hour or kilometer per minute. Yeah, beautiful. You can just say that 1.2 kilometer per minute. It's finished. So what are you doing? Is it 1.2 kilometer speed or you are doing an averaging? You are giving an average value. Now let me make it. This is only algebra. What you can do is the time is given, distance is given. You can divide and get the velocity, and that's actually algebra, the subject of algebra. But today now we are dealing not algebra. So 1.2 kilometer per minute is multiplied by 60 will become 72 kilometer per hour. That is the answer. A wise answer could be 72 kilometer per hour, because generally we don't talk in terms of you have CGS scheme and no MKS and all that. So you know generally it is kilometer per hour is the speed in which we talk about mileage and all that. Practical. I am not talking about physics and mathematics. We are talking about practical. So 72 kilometer per hour. We don't say 1.2 kilometer per minute practically. Now let me ask you one question. What is the speed right now? If that is asked, no 1 minute is given, no distance is given. Right now. So what is the time? Time duration is given 0 minute. So what is the speed? In 0 minute, how much time can be traveled? 0 second, 0 hour. It can only be 0 meters. So the answer will become 0 by 0 if you do it algebra. And the answer will be I don't know. So what do you do generally? You divide them over a period and average them and write. Now let me ask you one question. Practically, when traveling by driving, I'm 100% sure all of you must have seen a meter in the vehicle which has got 2 meters. One is odometer and the another one is speedometer. When you look at it, it will give you 70, 70, 60, 50, keep on vibrating. How is it computed? How is the meter electronically displaying in front of you on the digital board? It is computing every instance. How is it computing instance? It takes an average. But that average will be during a span of time. But the meter is moving every second, every spot of seconds. Every moment, every time it is moving. So it's not average. It's at that point of time. So what is the speed? Now if you ask, immediately you can look at the meter and say it is 70, 65, 67. It's not averaging over a hour. It's not averaging over a minute. It's not averaging over a second. Actually, that computation is done using calculus. So if somebody asks you where is the application of calculus, you can see, look at your odometer, look at your speedometer, how is it done. Okay, I'll give you another example. Assume that somebody is driving on a road. You can see a radar gun by a police, or maybe you have cameras kept there. It will tell you your speed was more than 60 km per hour during that time. It is 62 km per hour, but you are supposed to drive only 60, therefore this much rupees fine. How is that meter computing the speed at that point of time? Because it's only one click. And that speed computation is done during your drive, the radar camera, the radar gun, it's called radar gun. That is calculating the speed at that moment using calculus. We have in physics many such examples. If you want to learn calculus, don't learn mathematics. You have to learn physics. You will have to learn physical science. Applications will come only when you see it in the ground. And seeing the ground and visualizing is more physics, chemistry, mechanics, electrical engineering, etc. than mathematics. Therefore, you must be very thorough with why people find it very difficult. Calculus is one of the most difficult subjects for many students. The reason is it is not exactly mathematics. You have to know Gauss law, magnetism, Faraday's law, maybe Maxwell's law, in which you have lot of imaginations, real life applications. It's not pure, so-called pure mathematics. It is the purest of mathematics because it's there in the real world. So anything which is infinite, which is in the real world with a lot of logic, you can put it in mathematics with a lot of animations added together. That becomes real calculus. My PhD is in fluid mechanics, heat transfer, therefore conduction, convection and radiation. The fluid flow. Convection means there is a flow. And radiation, it is flowing in the air with a lot of boundary conditions. What you get, or the problems which I solved probably 35 years back, is integral partial differential equation. Integral partial differential equations. Just now I was talking to my son saying that I have got a talk on calculus, applications of calculus for one of the colleges in Kerala, Varkala SN College. And my son is doing PhD now. He is writing his PhD thesis, and that's in nuclear physics. So I just casually asked him, where is applications of calculus in nuclear physics? Neutronics. The subject is neutronics, which is in reactor physics. On the floor, when you add a neutron, the optimum number which you have to add for your reactions in the way you want it. If you want to compute, the whole equations are integral partial differential equations. I remember I had a friend of mine who was doing PhD in diffusion equations. And the diffusion equations, when you write equations, the equal equation means left hand side, right hand side, in between you have an equal. So 4 pages you write left hand side and then put an equal, and another 3-4 pages you will have another set of equations. That long is equation sometimes. You cannot solve it that easily. So what do you do is, you look at lot of numerical solutions. So some of the calculus problems are solved using numerical solutions. Therefore, if somebody wanted to get into numerical analysis, you must have a strong background of algebra, calculus, and then add on to different branches of mathematics, including programming. By now I guess I must have told the calculus, if you want to understand, you must understand different branches of mathematics. Now, if you look at space technology, calculus is used extensively. Most of the modeling is through calculus. There are beautiful books, uses of calculus in real life. I think it's John Marsh who wrote the book. Yeah, John Marsh. These are all great mathematics. But how do you realize it? Just now I said geometry. Now what do is, draw a line. You have an x-axis, you have a y-axis. Draw a line. What is the equation of line? Y is equal to mx plus c. Y is equal to mx plus c. As m changes, the slope changes, because m is the slope. I am changing the slope. This is x-axis. Now this is the angle. Angle reduces, your slope increases. This is m. The angle is m. Now what do is, differentiate it, dy by dx. Immediately you will get m. So what is differential, that will give the slope. So what is dy by dx? One single answer, dy by dx will give you the slope. Simple as that. Now what is c? Where you are placing it? The c in the y-axis, you are keeping it here or keeping it little above or below. That is what the c says. M is the slope, c is at what height you are keeping it. Can you visualize like this? Now let us take x equal to y. That means slope is 45 degree. 45 degrees, 1 unit by 1 unit, if you take this becomes root 2. So 1 by root 2 will become the slope. Actually that is trigonometry. So I am teaching you trigonometry and geometry and algebra together. This is x-axis, this is y-axis. This is x equal to y. Understand, x is equal to y passes through 0. Angle is 45. This is 1 unit, this is 1 unit, this becomes root 2. And 1 by root 2, opposite side by hypotenuse or adjacent side by hypotenuse. Both cos and sine. Cos theta and sine theta become 1 by root 2. And that is the slope. Now, immediately I will tell you what is integration. What is integration? If you have got a curve like this, line is also a curve. Simplest form of curve is line. If you have a curve like this, when you project it to the x-axis, how much area is covered? That area is called integration. So, y is equal to x is the equation. Y is equal to x is the equation for this line. Now, what is the integration for y is equal to x? X square by 2. Is it the area? Yes, because x is the distance here, x is the distance here, because x and y is equal. This triangle is a right angled triangle. For a right angled triangle, you know the area is x square by 2. Why? Because the two triangle becomes the square, and this is exactly the center line. X square by 2 becomes the integral. So what is integral? Y is equal to x is the line like this. Integral is integral of dy by dx with respect to x becomes x square by 2. So that is the area. Integration means adding together, that becomes area. Differentiation means cutting into pieces to look at a small instance, like the speed which we measured, not 1 hour, not 1 minute, not 1 second, that moment. That is what we do. Doctors also do that. They don't want our blood pressure, the heart rate, to be computed over 1 hour. At that moment when he touches, what is the heart rate? Actually differentiation, calculus, heartbeat, heart pressure. You have got a oximeter. Keep the oximeter, it will tell you. Compute it, calculate it. Calculus. The stock market variation in the economics. The rocket which runs at that point. What is the pressure, temperature? It is not one parameter, multiple parameters. So therefore it becomes not single variable calculus, multivariate calculus. At given point of time, how many virus is around your, how the pandemic, how the epidemic, how many bacteria are there, viruses are there. You do an environmental model, environment science. What you do is zoom inside and look at it. Suppose you have got, what is the difference? Assume you have a curve. And in that curve, at one point you want to know, you zoom inside, that curve becomes a small line. So what are you doing? At that small line, zoom, a parabola, zoom inside, you get a line. That line, what is the tangent? That is the slope. So now what you see? Derivative, we know, cutting into pieces. So what is integration? Opposite to derivation. Adding together, that's integration. So therefore when you talk about calculus, limit, function, derivative, integration, infinite series, so algebra becomes analysis. Algebra is finite, a, b, c, polynomial. When a, b, c, d becomes infinite number, it becomes series, sequence. That is what we call it as analysis. So infinite number of things, when you connect, algebra changes to analysis. Therefore calculus takes you from algebra to analysis. So understand how many subjects you must learn. Why people find calculus difficult? Because algebra, trigonometry, geometry, analysis, everything has to be understood carefully to understand calculus. But don't worry, at the graduation level, BSc and all, calculus is not, it's only elementary, introductory calculus. So you need little bit of arithmetic, algebra, and then calculus. But you need to be very strong in arithmetic and algebra, little bit of trigonometry, because most of the examples are taken with the cosine and sine. Therefore derivative of sine becomes cos and cos becomes minus sine, and etc, etc. Unless you visualize, you will not be able to understand this. That's why trigonometry also has to be understood visualizing. You can see some of my classes on trigonometry, or maybe we can discuss. I can explain one to one. Maybe a bunch of students can come together to learn visualizing trigonometry. Probably I can do that. If you don't do that, very, very boring. If you do that, oh, what a great science is mathematics. Differential equation, calculus of variation, even chaotic theory, chaos physics. How do you model them? When you open a pipe, narrow linear flow, the pipe water will go line by line like a string. But after some time when you open it, whoosh, it just spreads out. And that is what is chaotic behavior. You want to understand this? Yeah, you need a lot of modeling. Even topology. Many number of folds, many folds. Numerical analysis. When I said topology, I remember my master's MSc in Cochin University. When I did abstract Banach space. I don't know how many of you know vector space, Banach space. You have got set which is a pure mathematics, set theory. In 8th class also students learn set theory. That's a pure mathematics. And in that set theory, what you do is, you can add metric. Therefore, distance can be derived. That is how you make group, inverse of a element, negative of an element, multiply two elements to get a null element, a unit element. That means you are adding metric, measurement inside that. Metric means measure. So you are adding measurement inside that. So when you add measure, I can always find a derivative because distance by time is velocity. Metric is given. That's why I can divide one by another one. So now what do I do? In Banach space, in abstract space, I define differential equation. That's what I did during my MSc, 1984, 37 years back. And that Banach space differential equations gives you what is called a degree theory. And that is actually a subject of study which is very close to graph theory. So I was giving the introductory learning of graph theory, and I was so glad that I had a great professor like M.R. Kaimal, who later became a computer scientist, head of the department in Thiruvananthapuram Karyavattam campus. So we had great teachers. See, what we do is pure mathematics. But later same pure mathematician became computer science head. That means because it became application. So there is nothing called pure mathematics and applied mathematics. It's all whether you can visualize it, when you can do it. So calculus is one subject which connects between abstract pure mathematics to applied mathematics. So why your math class is boring? Because you are not able to visualize. Why are you not able to visualize? Because you elementary knowledge is lacking. What to be done? Don't leave it like that. Have discussions more so that you get the ability to visualize. You have spatial relativity, general relativity, quantum mechanics, Fourier series. All these subjects is what is dealt in physics, which is part of calculus. So calculus for physics, or physics for calculus, or calculus with the physics, or physics with the calculus. That is actually to be understood. The physics makes lot of usage of calculus. Therefore, you cannot separate them. The classical mechanics, electromagnetism. What I told, radiation is electromagnetism. Energy, conservation, electric principles, optimization problems. See, when you have a curve, at that point, what is the angle? So what you do is, you take a curve, draw the tangent there. The curve goes like this. At each point it varies. So what is to be done? At that point you want to calculate, you will have to take delta x and delta y and put them very close to 0. That's why you do delta x tends to 0, delta y tends to 0. When t tends to 0, what is s? The distance when t tends to 0. ds by dt. Delta s, the distance by time. That's what I asked you, what is the time, the speed at this point of time. Actually, all these are possible only when you have a change, a movement or a motion. Business has this ability. Every moment it is changing. The price is varying. So it's called a gradient graph. Elasticity in economics. What you do in physics is also there in economics. I remember in 1987 I was teaching engineering students, 1986-87, 34 years back. And my class happens to be calculus, and I was teaching electrical engineering students. So what do? How do I explain electrical engineering? You have electricity lines. You must draw one post and the another post, two posts. Generally the distance is 50 meters, say 75 feet. And you have a line connecting these two. You can see, draw a line, electric line. 1, 2, 3 lines are there. And what will happen when they stretch it and tie? You will become a straight line like this. So that's how it is supposed to be, a straight line, electric line, right? Two pillars and straight line. And it never be like this. Why? Because the electric wire
Sag.
sagging, that's called sagging. Harsha is an engineering graduate, so sagging, that is called sagging. So how do I explain it in a classroom? I remember I was teaching in Vishwesharaya College of Engineering in Bangalore, started by the great Mokshagundam Vishwesharaya himself, and my room number was room number 310. I was seeing students sitting in the last bench because nobody likes to sit in the first bench. People will always sit in the last bench, and old engineering colleges bench is not a 3-seater, it is like a 7-seater, too big, and too old college. Maybe the bench would have been there 100 years. You can imagine what will happen. There will be a sag. Why the sag is coming? Because the bench is too long. Why the sag in electrical engineering? Because two poles are far apart. If it is very close, sag will become less. And next, the weight of the wire. If the wire weight is less, the sag will become less. So how many parameters now? The sag, how much it will dip down, depends on the distance between the poles. It depends on how much is the weight of the wire. And not only that, you know, this sag will tell you how much electricity is lost. The sag is more, electricity loss is more. Because instead of traveling straight like this, it has to travel like this. So it has to travel longer. And it is very close to earth. Because it is close to earth, there will be an earthing happening. Accidents can happen more. Electricity can go more waste. I am 100% sure my children who are listening to me will never forget this. This is actually multivariate calculus. Optimally, what should be the distance? You cannot have very close post. How much distance it has to be for the wire? What weight it has to be for the less loss in electricity? How do you listen to this? How do you understand this? Unfortunately, even in engineering colleges, the basic textbooks are not referred. I remember 35-36 years back when I teach, I was looking at one of the best books in advanced engineering mathematics, Erwin Krzik, ERWIN, Erwin. That's good enough. You will get beautiful visualization of mathematics. Not only calculus, every subject in calculus, complex analysis. You wanted to see the applications, every mathematics. Unfortunately, MSc, BSc, PhD who become teachers in mathematics also don't look at these textbooks. I have not seen in mathematics libraries Erwin Krzik books. Only in engineering colleges they keep in library, but no student reads that. They will only read question and answer for getting marks. Yeah, you will pass. Pass mathematics is very simple. But understanding, visualizing is very difficult. Learning is simple. Many children will learn. Oh, I learned mathematics. Useless. Did you understand mathematics? Did you visualize mathematics is my question. Advanced Engineering Mathematics by Zill, Z-I-L-L, Zill, Dennis Zill, I think, yeah. Dennis G. Zill, beautiful book. Michael Greenberg, another best book, Advanced Engineering Mathematics. You read those books, then you will be able to visualize. Then you will be able to teach like this. So what is derivative? How to be introduced? It's an average of slope, but average with infinite small. The change delta x by delta y at the closest applications, many. So geometrically, you can visualize, you can differentiate by coming close to zero distance and understand further the Lebanese, Newton. How did they do that? In Newton, there are many first law, second law. Momentum is important. Rate of change of momentum. Mass into velocity is momentum. How do you understand mass into velocity? Suppose there is a heavy item and a small piece moving with a less velocity going to hit, then impact is less. But assume that this becomes a bullet. Weight is less, but velocity is too large. I am sure that will hit and this big item will fall down. So the impact, the velocity matters. Assume that you are standing and you are walking and then hitting a big train which is standing there. Impact will be less, both to the train and to you. But you are standing, a small cycle is coming with high speed. The impact will be more. So it is not the weight, it is not the mass, it is mass into velocity which gives the momentum. Velocity is calculus. At that point, what is the velocity? So the change in velocity. So Newton's law, second law, exactly application of calculus. Now rate of change of something, unless it is influenced by an external force, it will continue to be in its states of rest or motion. Calculus. Unless it is influenced by a force. That influence at that moment is what is calculus. There are a lot of beautiful books understanding calculus in terms of physics alone. The physics approach, the intuitive and physical approach of calculus. Making calculus very easy. Thomson's book, I think. The Martin and Thomson, I think they wrote it together. I don't know how many of you know Sham series. When we were all students, we used only solved problems in calculus. Look at Sham series books. So rate of change is what is calculated. So who did this calculation first? Obviously Newton. So who is the inventor of calculus? I don't want to get into controversy. Therefore I have to give credit to both Newton and Lebanese. The go-different Lebanese. Both of them did together same time. They both lived together in the same. One is in London. Newton is from London, where Westminster's Abbey. I remember walking on the street where Sir Isaac Newton lived. 1642 to, I don't remember exact date, approximate 1700. He lived how many years? Maybe less than 80 years. Yeah. So 1726, 1642. That's a time when Newton lived. Approximately same. Lebanese was 4 years younger to Newton. So 1646. That's how you remember dates. 1642 and 1646. He died 10 years early. 1716 he died. So Lebanese and Newton both did calculus together. Inventions of calculus together. Both were great philosophers, scientists, mathematicians, physics. Both. One is from Germany. Lebanese is from Germany. But then both of their approach was different. So there is no contradiction. Nobody copied that from somebody else because approaches were different. So discovery of calculus can be credited to two scientists. One Newton, second one is Lebanese. Did they meet each other? No, they never met together. They lived together in London. I think at least sometime they would have been in London because from Germany people traveled to London those days. That Sir Isaac Newton Isaac Newton got more glorification because he got a Sir title. He was very close to UK and he was in UK, whereas Lebanese was in Germany. So language was German and here it was in English. Therefore publication would have been much easier for Newton than Lebanese. So it's all, both of them are in 16th century. Understand that last week I was giving a lecture on cyclone because Kerala coast up to Bombay was, and last week we were supposed to talk. Because of cyclone you postponed that for a week. I was supposed to talk taking examples from cyclone because most of the predictions are based on the satellite will take a picture and see one cloud here, another cloud here, and it keeps on moving. So once it keeps on moving, what do is we model the movement of this cloud and model the movement of this cloud and see at a given point of time where they are going to meet. At that place the rain will be there. Similarly, the cyclone, the movement of the air. There is a talk given by me last week in Radio Asia. It's there on my YouTube. That movement of the cyclone will tell you where it is moving. The talk is in Malayalam. It will tell you where it is hitting, but unfortunately it will not hit there, it hit somewhere else because the model is mathematically calculated to check whether we calculated May 4th it will come to Oman coast and May 16th it will come to Indian coast. Maybe Kerala it will get 3 days early. From there it takes 4 days to travel. So the distance and the movement is computed with the velocity to check where it will reach. Almost predictions became very, very successful. Now, the predictive models on global warming for long term, 140 years today, how is the climate change? Most of the models you have maybe 16, 17 models. I remember I studied 17 models of global warming and found that most of them doesn't work because the data itself is bogus. Otherwise, model becomes good. So it has got a lot of variables to be added, not 1, 2, 3. So it will become multivariate calculus, different types of variables, the large number of variables. So single to multivariable. Multivariable is, multi means many. Too many variables will be there. Like these are main applications of calculus which can be seen. Weather models, meteorology department uses it thoroughly. Okay, observations, predictions, geographic information system, that's my subject. Use the satellite image to map and find out when the flood comes, how much area will be getting flooded, because it is not a rectangle or a triangle. The boundary varies as the water rises up. The boundary becomes not a polynomial, not a polygon which can be defined. Not even a polynomial you can define. It will become zigzag because the flood water goes up. The spatial distribution becomes more. Underneath, the topography, the surface, under surface coverage, the topology becomes different. That's what is called a topology. It becomes undefinable. So what you do is, you do a topographic model in which the spatial model and the volume computation, the surface computation, surface you can measure, and from there you have to compute the volume. So a lot of relations and functions are used. Geographic information system, but you cannot forget geography there. Geography plus information system, that is mathematics together is geographic information system. We have got an MTech in GIS, which I teach them at a higher level of MTech in GIS, where we have got a lot of applications of calculus, day-to-day basis. We want to know applications, look at geographic information systems. So on the ground, water flooding to the space travel. Moon mission. How are we sending a rocket to the moon? Exactly the trajectory is drawn, the path is drawn, and check whether your vehicle is moving exactly following the path. Is it a exact following or how much is the variation? At every moment you must know how much distance it is moving away from the predicted path, so that you know how much correction has to be given, and that correction, which booster has to be. No, last week I gave a talk on rocket in the same Radio Asia program in UAE. Booster has to be adjusted according to that's because the Mars mission, the moon mission, or such failures are when your predictions are wrong, or maybe your calculation is wrong. So these are all different features of calculus where you can apply, how you can apply, and reverse of that becomes integration. The geographic information system is full of integration. So what you need to know trigonometry, you need to know algebra, you need to know polynomial, quadratic, exponential, logarithmic, sine, cos functions, and etc., etc., so that your calculus becomes very smooth flow. Okay, so that is what is exactly calculus. That is where the small computation, which is infinite small, which is mathematics. When you do it in finite, it becomes physics. When you do it in finite, it becomes normal algebra. Otherwise it becomes indefinite integral. Some boundary is given, it becomes definite integral. You have got improper integral, double integral, triple integral, and many scientists, based on their application, like a Cantor, you will see Cantor, you will see Riemann-Stieltjes integration, Taylor series, Newton, Barrows, Euclid, Feynman, Wiener, you name anybody in physics, Archimedes, all of them have used calculus extensively. Archimedes, you know that the surface area and the volume computation, when something puts down, how much water is going out, that is Archimedes. Exactly integration and applications of calculus, right? Better navigation system, how much water disposed, what Archimedes says is what is used for modeling your vehicle in the navigation, both in the spacecraft GPS navigation and the navy, which uses in the water. Both are navigation only, right? So it's all measurement to its maximum precision. Economics, measurement to the maximum precision in relationship between the income and the prediction, the efficiency of how much product, where you can sell it, all that market predictions, the payment predictions, the survey of involved in economics, which gives inputs, then the modeling is done, right? These are all done with a very large scale for a model which needs to be applied for a specific problem continuously. We have very large scale integration, which is VLSI. You have any electronic students, ask them. The electronic students will tell you where it is being used. So maximum applications of VLSI in electronics, it's all done through calculus, various fields of science. So we have seen biology, okay, you have the number of lions, number of tiger, number of deer, number of rabbit. If tiger is more, rabbit will become less, because they will all eat the rabbit or the tiger, or the lion will eat the deer. The number of deer becomes less, the forest area becomes more. When forest area becomes more, the grass becomes more. When more rabbits and more rat will come. So the number of each one of them in the ecological chain, the food chain, the ecosystem, balancing of ecosystem, full differential equations. Y will become number of lion, X will become number of deer. In the second differential equation, Y will become number of deer or maybe a rabbit, X will become the quantity of grass. You can model the ecology, the rate of heat flow in geology under the earth. When a psychologist treats The performance of my treatment can be measured through psychological models. Sociologically, how the rumors are spreading. It's spreading more than virus some of the time. Actually, Newton's law has got a lot of applications in psychology and sociology. When the Newton's law says that the reaction depends on the action. Yes, if I keep more rumor, the other fellow also will add rumor to me. Physics is full of science. You can have a lot of natural science applications in psychology and sociology. I remember giving a lecture on how the pendulum movement can be associated with daily life. There is some other lecture, you can follow that. So the derivations in biology, psychology, sociology, numerous examples. I gave examples in economics. The commodity produced, the cost depends on the company. So the marginal cost, marginal revenue, marginal profit will become the difference between these. And that economics will tell you the price elasticity. That's called the price elasticity. It's like a curve which changes. Elasticity. The demand of price elasticity of demand. And supply and demand curve. Supply and demand curve. These are all what is commonly used in economics. I was teaching business management students. That time we used a lot of supply curve, demand curve, and how do they relate. The elasticity of the relation between supply and demand, one variable to another variable. They're all different variables as far as mathematics is concerned. So microeconomics, macroeconomics, engineering, chemistry. Just now the radiation or maybe the nuclear reactor. What is explained is how many neutrons, electrons to be added to get a reaction. The rate of reaction. Rate, whenever the rate comes, there is a change. Rate of change, rate of reaction, and the how much pressure you have to give, compressibility in chemistry, the pressure, temperature, and the chemistry which you add, the volume of the chamber which you are making the reaction happen. All that becomes connected to each other. In mathematics itself, you have got a lot of applications like monotonic series, concave, convex, curve, Newton, applications of Newton's, the temperature, pressure relationship. I spoke most of them. I think I spoke degree theory also I spoke. So, building construction, meteorology, earth, structural engineering, architecture, lot of predictions on earthquake. How does it affect the structure? The soil structure, how is it changing because of the spontaneous bombardment under the earth, maybe with a bomb or maybe like an earthquake. So that means civil engineering. How the drainage has to be connected, the slope how much is to be given, how much water has to flood and flow, hydraulics in that, the electrical cable length and the distance between the posts, the space, astronomy, analytical geometry, applications in algebra, bacteria, fungus growth, pandemic, epidemic, the patient diagnosis, most of the heartbeat, the curve, the electroencephalograph, the brain movement, all that, the cardiac or the brain, how the monitor the growth of bad cells in a body, that is cancer, how the controlling of blood cells happens during a surgery, modeling of replacement of organs, how the curve has to be fit exactly which can fix it there, how anesthesia works, how psychology works, how the cardiology works, pharmacology, when the medicine is given, how the chemical parameters in my body changes, how the drug side effects or the effect happens, how my kidney function happens, which are all I think When I was learning my masters in psychology, we were learning like a Galt equation, GAULT, Galt, which is full of biology modeling using calculus. So psychology I told already, right? I think there are plenty of such applications which I can, or I already have told. I think I spoke almost an hour now, or more than an hour. That's good enough. I think we should open it up for questions. If you have, I'll be very glad. I'm so glad that I could speak to you on a very generic topic on calculus like this, because it is going to be an asset for me to think myself on a subject which is very close to my heart, which I could visualize. If there are few questions, probably I can answer. Otherwise, namaskaram and thank you. As usual, I don't know. History department response was too bad. Let me see how many real mathematics students who love to learn mathematics are around, who will have some questions. I've got some of my students who are following me regularly are also joined here, and I'm glad on that. Right? I have also few students who are part of my regular learning program, and generally we don't see students, yeah, I am joining, will get a message, but I got messages saying that no, I am unable to join. Inability is what is shown, not ability. What is negative is what is spread than positivity. I wish some good students get some benefit, and then hope I enjoyed anyway. So thank you for this opportunity, Dr. Preeta and Sanma and Dr. Neelima, for allowing this to happen. Glad. Thank you. Thank you very much.
Thank you, sir, for your nice presentation and giving to us on the calculus. It's nice knowledge acquiring areas to the students also. And any student from student side, any questions or anything, please ask.
I am so glad that Anaka answered it here. Chil Swarupam, it is not because I don't know, I just asked. I wanted to see whether people responded to any such basic questions. Chil Swarupam is Chit Swarupam. Chit Swarupam is, by this prayer, I am going to visualize God as I am visualizing a mirror. Mirror is what is called a Manam Darpana Samanam. Manam, my manas, my mind. So there, Chil means my manas. My manas means my chit. Il and tu both are used in Sanskrit together, same way, without any ulsavam, utsavam, aulsukyam, outsukyam. Tu and il can be used together. So generally Kerala people will use il, other language people will use tu. So Ishvara Swarupam is Chit Swarupam. Chit Swarupam is Sal Swarupam. Sal Swarupam is only when I can see inside my manas, because Manam Darpana Samanam. Hridaya Guhara Madhye Kevalam Brahma Matram. Inside my Hridaya, I am able to see God. That is the essence of that. And Anaka, so happy that you have answered it. Thank you. Thank you for that answer. Yeah. If you have questions, you can ask. Otherwise, if you want to put it in chat box, you can ask. Otherwise, you can always get back to me on my telephone at any point of time. I love to talk to students on one-to-one also. Maybe I'll ask for a Google Meet, and then so that whatever I speak can be posted onto my YouTube, so that it can become useful. I may go, but those will stay for a long time in this world. So I posted my 9447437948. If you are good students, if there is at least one or two good students, that's good for me. I am only searching in my life for good students who will follow. One person gets benefit out of a lecture is good enough. Not 80 around here need not respond. One student makes a beautiful note, say that this is what I learned. I love to post this. When I post the YouTube, I will post that this is the note sent by so and so student from Varkala Mathematics department from SN College. I'll be so glad. And that will stay there all throughout the world. as long as YouTube exists, www exists, where, when, how exists, that will also exist. So I'm glad if somebody can put some comment, or maybe somebody can write something and then post it. Maybe after the YouTube posting is also good enough, or maybe if you have some questions, I'll be glad. Yeah, as usual, silence. People are all highly meditative students. So thank you. Good enough. Glad.
Sir, shall we go to the next? Sir, shall we start the next student presentation?
Yeah, mine is over. If there are no questions, that's how students are trained in classrooms. So good enough.